Like I mentioned before, we will be using graphing utilities a lot, be it using Desmos or graphing calculators. In class, we're going to be using graphing calculators. So a lot of my um, examples on the videos will be using the graphing calculator. So I highly suggest if you did not get one previously when it was required in middle school, get one now, and you'll need it in college. It's going to be helpful. You can use Desmos, but it doesn't always do the same things. So um, here's the standard viewing window that we usually use on our graphs. So we have this equation shown in the standard viewing window. Now you can imagine if you were zoomed out, you wouldn't see too much. If you zoom too far in, you wouldn't see all the graph. So it's really important to have a good window when you're doing a graph. So let's just go with an example of why a window would be important. So for a certain city, the cost of obtaining drinking water with P% impurities by volume is given by this equation. We can tell that P is never going to be 0 because you can't divide by 0. Now, if I put this equation into my calculator just as it is, let's just go here, clear whatever else was in there. I'm going to go alpha y equals to get a fraction, 0, 0, 0, 0, over, I'm going to call it x, minus 1200. Right now, my window is standard. That's the 10 by 10 window, 6. And when I look at this graph, I see nothing. So we have to make some changes. So the next thing we need to change is, let's start with the x values. Well, if P is a percent, it's going to be from 0 to 100. So we're going to start there. We go to zoom. Oops, not zoom. Window. So here's where I can change all that. So I'm going to go from 0 to 100. Well, let's see if I see anything. Ooh, I see the bottom of a graph, so I'm not tall enough. I also don't really think I'm going to have too much below the graph. So what I think I want to do is kind of play a little bit. I see this 120,000. So I know I want to get up there. And I do want to see a little bit of the x-axis. So I'm going to try some stuff. So I'm going to do this in a smaller pen. So right now, we have our x min, whoops, I misspelled min, is 0, and x max is 100. We may play with that a little bit. Y min, I think I'm going to go with 0. Actually, I'm going to go a little bit below that. So let's go like, if I've got to get all the way to 120,000, I'm going to do like negative 100. And I'm going to go all the way up to 120,000. And let's see if we get a better window. So press window. And I'm going to do this as negative 100, then 120, 1, 2, 3. Notice that I went a little bit too far. I'm not seeing it really good. So I'm going to play a little bit more. And I think I want to, let's try something. Let's go to I don't know, 500 or 50,000. Is that going to be too much? It's actually not too bad. But I'd really like to see, like, if it ever crosses the x-axis. So I'm going to change something here. I'm going to change this to be like 125. And I'd like to see a little bit more on the other side. So I'm going to go negative 25 here. And then I'm okay with that. And we went 50,000. Let's see if that makes it a little easier to look at. Okay. And we see a little bit better. I can't really see where it's crossing there, but we can always use a table or the trace feature. So I'm going to try the trace feature. And right there, it's at 50% purity, and we have 1200. And notice as I go down, both the X and the Y are going down. And once I get past that 100%, the cost is going negative. So that's not good either. But we can kind of play with the windows. And that's what we'll be doing here in a second. Okay, so here's another function, and it represents the number of women in the workforce in the years past 1940. So we're going to graph this function from 0 to 85. So they actually give us what we should put in for our min and our max as far as that. And a lot of times it's going to be best to go back to a standard window first. And so I'm going to press zoom and standard just first. That's always a good place to start. And notice that I do see where it's crossing the x-axis here. Because when x is 0, y is 0.07, so that's really, really small. But I'm going to change my window. It said to go from 0 to 85. And notice that it's way too tall. So let's try, oops, go to window. Having negative 10 women doesn't make sense. Let's go 0. Let's go 100 here. Let's see what that does. Okay, so I can see a good graph here. And notice I just kind of was playing with it. Find the value of y when x is 60. So I could go to the table and go for 60, but that would take forever. The easiest way to do it is to hit trace, and all I have to do is type in an x value, so 60. And it jumps me straight to that point, which is wonderful. So when x is 60, that means my function at 60 is, it was 64.87. So let's think about what that means. X was the number of years past 1940. So in the year, in 2000, there are, and I'll say approximately, because this is based off of a model, 64.87 million women in the workforce. Use the model to estimate the number of women in the workforce in 2015. So that would actually be when X is 75. So we want to find F of 75. So again, I'm going to hit trace because it's easier than using the table. And I get 75.445. So in 2015, there are approximately 75.445 million women in the workforce. Okay. So we're going to look at a few more things that we can do with the calculator. The first one is called the x-intercept method with the calculator. And we can take any equation and rewrite it so that it's solved with 0 on one side. So set it equal to 0. Whoops. And then we'll enter the non-zero side into the calculator. We have to play with the window. But we'd want to find the x-intercepts because that's what would make it equal 0. Okay? So I'll show you that method, and then I'll show another method as well. Let's see if I'm going to show that today. I can show that tomorrow. Okay, so if I get everything on one side, that means I'm going to, and I don't even have to be really fancy about it because the calculator doesn't care. 5x plus 1/2 minus 7x minus 8 equals 0. So I just subtracted everything from the right side. In the calculator, y equals 5x plus 1/2 minus 7x minus 8. And I'm going to go with a standard window first. Do I see where it's crossing the x-axis? I do. Now, I could look at the table. I could guesstimate because it looks like it's around 4. But there's an even better feature, and it's called the 0 feature. So I'm going to press second calc, and the second option is 0. And when it asks for left bound and right bound, we're being asked to narrow down the calculator. So right now, my little cursor is on the left side of that 0. It's to the left. So I'm going to press enter. Right bound. So notice there's a little arrow marking where I marked that. And now I'm on the right side, and it puts another right arrow. So it's telling the calculator, look between these two little arrows. Then it asks you to guess. I don't really care about guessing. And it gives me my 0. It gives me the solution to that equation. If I plug that back in, it would work for both sides of the equation. Now, there are other ways to do that. We will learn those throughout, but that's a nifty little trick.